Well, hello and welcome to this exercise on joint and marginal probabilities, S1 iGCSE type statistics question. And it says events A and B are such that the probability of A is equal to 0.5 and the probability of B is equal to 0.3. And then it says evaluate the probability of A union B when both events are mutually exclusive. Uh, in other words, the sets are disjoint sets, so there is no intersection. So in this case, the probability of A union B is simply the sum of the two probabilities in this case, and that will be 0.8. Right. For part 2, it says both events are independent, and it says complete the table below. Right, and the table is here. That's it. Well done. Okay, right. Now, to do this, firstly, we start with what we already know. We know that probability of A is 0.5, and we have 0.5 there. And similarly, the probability of B is 0.3 there. Okay, 0.3. Now, in here, we should be A prime. Now, this is similar to a situation where we could say A is for having a disease and A prime is for not having a disease. Or it could be a 1-0 situation. And B could be a situation where you have the symptoms, and B prime is a situation where you've not got the symptoms. So that's B prime. Now, having done that, we now have to fill in this cell here. Now, this cell is the probability of A intersection B. And that's the product of 0.5 and 0.3, and we end up with 0.15. Because we multiply them together. Now, if that's 0.15, the probability of A intersection B prime will be 0.5 minus 0.15, we end up with 0.35. Okay. Now, similarly, in here, the probability of A prime intersection B will be 0.3 minus 0.15, and we end up with 0.15. Now, the sum of the probabilities has got to be 1. So we have going to have 1 in here. And if that's 1, the probability of A prime is going to be 1 minus 0.5. Similarly, the probability of B prime is going to be 1 minus 0.3, and we end up with 0.7. Okay, right. And for the last cell, that's got to be 0.7 minus 0.35. We end up with 0.35 there. Okay. Now, note that the probability, the sum of the probability of the intersections adds up to 1 as a check. Okay, now we want to evaluate the probability of A union B when A and B are independent. So we end up with the usual formula of probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So 0.5 plus 0.3 minus 0.15, and end up with 0.65. Okay, now I've got sort of a Venn diagram which is not quite complete. We got 0.35, 0.15, and 0.15 there. That's in the table. Okay, now the next question then says, given that the probability of A union B is equal to 0.7, find the value of the probability of B given A. So that's gone up from, it's gone up by 0.05 to 0.7. So we need to decrease this now by 0.05, and that becomes 0.1, and add it to this one, that becomes 0.4 is still there. And we have 0.1 there. Now, I'm not worried so much about B because we're looking for B now. Right. So, we need this value here in order to do this calculation, because that value gives us the probability of B intersection A, or if you like, the probability of A intersection B. It doesn't really matter. So we need that value. Now I can do it by what I call intuition here, or I can do it by calculation, which is the preferred method, and here it is. The probability of A union B we know is the probability of A plus probability of B minus probability of A intersection B. We now want to make that the subject. Okay? So which becomes probability of A plus probability of B minus probability of A union B, which is 0.5 plus 0.3 minus 0.7, and we end up with 0.1. So we now got our A intersection B. So we cannot do our calculation there. We want to find the probability of B given A, and that's going to be 0.1 divided by 0.5, and we end up with 0.2. Now, I hope all that made some sense, and please subscribe. Thank you for watching, and bye-bye now.